Hi, welcome to the first lesson for AS Physics. Today I'll be talking about the first chapter in your syllabus, which is physical quantities and units. Now, if you want to make sense of the world around us, there are certain things that we can measure. For example, the length of a pen, the mass of a person, the volume of water inside a glass, or perhaps even the amount of time that is elapsed after a certain event. Now, features that can be measured are known as physical quantities. A physical quantity must have both magnitude and unit. When you're talking about magnitude, magnitudes can be thought of as just numerical values or numbers. If you see that something has numerical values or numbers, those are considered to be magnitude. There are two types of physical quantities, base quantities and derived quantities. For base quantities, these are the most basic quantities. They cannot be expressed in terms of other physical quantities. As part of your syllabus, you are required to remember 7 base quantities and their units. The table below lists the 7 base quantities. The first one is mass, measured in kilograms. The second one is length, measured in meters. The third one is time, measured in seconds. The fourth one is electric current, measured in ampere. The fifth one is temperature, measured in Kelvin. The sixth one is amount of substance, measured in mole. And the last one is luminous intensity, measured in candela. Luminous intensity is actually a measure of brightness. The brighter something is, the higher is luminous intensity. Now, when you're doing the questions in AS, you will mostly see only the first 5 quantities. For amount of substance, which is measured in mole, you will only see this in A2. Whereas for the last quantity, you won't need to worry about it because it's not covered in the syllabus. Other than base quantities, we also have derived quantities. Derived quantities are obtained through the product or quotient of other physical quantities. When we say that they're the product of one another, it means that the physical quantities are multiplied with each other. When we say that they are the quotient of other physical quantities, it means that they are divided with one another. Units may be multiplied or divided with one another, but never added or subtracted. So if derived quantity is defined as the product or quotient of other physical quantities, it would mean that derived quantity units is a combination of units. It's important to know that all derived units can be expressed in terms of SI-based units. However, certain derived units may be expressed in terms of other special SI units instead, such as Newton for force, joules for work, and watts for power. Now, consider a number of SI-based units, kg meter per second squared, kg meter squared second negative 2, and kg meter squared second negative 3. If I were to ask you to guess the physical quantities that these units belong to, you have difficulties in guessing them. Kg meter per second squared is actually for force. Kg meter squared second negative 2 is actually for work, whereas kg meter squared second negative 3 is actually for power. Now, if I were to just give you the special SI units, Newton you immediately know is for force. Joules you will immediately know is for work or energy. Watts you will immediately know is for power. Hence, if I were to just give you the special SI units, it will make your life a lot easier because you'll be able to see what physical quantities they belong to. This is a table that has a few common derived quantities. You are interested in finding out the SI base units. When you want to find the base units of a certain quantity, the first thing you will do is to find the defining equation or any other equation that has that quantity. Then the next thing you will do is that you will sub in the base units into the equation and simplify. Once you simplify the expression, that resulting expression will be the SI base unit for that quantity that you are interested in. We'll start off with the first example for velocity. Now, velocity, you know that is defined as distance over time. So the unit of velocity will be the unit of distance divided by the unit of time. When you see a square bracket over a certain physical quantity, it means you are referring to the units of that quantity. Here, when I have square bracket over v, it means that I'm referring to the unit of velocity. When I have a square bracket over s, I'm referring to the unit of distance. When I have a square bracket over t, I'm referring to the units of t. So, units of distance is meter, units of time is second. So when I simplify this, I will get meter per second. This is the SI base unit of velocity. For acceleration, acceleration is defined as velocity divided by time. So the unit of acceleration will be the unit of velocity divided by the units of time. So units of velocity, you already found it in the previous example. So it's meter per second divided by the units of time, which is second again. You will get meter per second squared. This is the SI base unit of acceleration. Now, if you want to find the units of force, you know that force is given by equation F equals to ma. So the unit of force is equals to the unit of mass times acceleration. So unit of mass is kg, unit of acceleration is meter per second squared. So your expression is kg meter per second squared for the SI base unit of force. Now, as I mentioned before, there are certain derived quantities where you use special units. In this case, force has a special unit of Newton. Now we move on to work. Work is defined as force times distance. So the unit of work is equals to the unit of force times distance. You already know the unit of force as kg meter per second squared. The unit of distance is meter. So you will get kg meter squared second negative 2. This is the SI base unit of work. However, the special SI unit for work is joules. Now, if we go to density, the unit of density can be determined from the equation which says that density is mass per unit volume. So the unit of density is equals to the unit of mass divided by the unit of volume. Unit of mass will be kg, unit of volume will be meter cube. So you get kg per meter cube as the SI base unit. Now, for the last example, we want to find the unit of power. Power is rate of work done. It is work divided by time. So the unit of power will be equals to the unit of work divided by the unit of time. Now, you've already found the unit of work here. So it is kg meter squared second negative 2 divided by the unit of time, which is second. You will get kg meter squared second negative 3. So the SI base unit of power is this one. And as before, there is a special SI unit for power, which is watts. In some questions, you will be asked to determine the units of an unknown quantity from a given equation. In the example here, the drag force F acting on an airplane traveling through the air is given by this equation. F is equals to half CD A rho V squared, where CD is the drag coefficient, A is the area of the vehicle, rho is the density, V is the speed of the vehicle. Determine the unit of CD. Now, for questions like this where you need to find the units of a certain quantity, it's often advisable to make that quantity the subject of the equation before you proceed any further. So F is equals to half CD A rho V squared, making CD the subject will be 2F over A rho V squared. Now, the unit of CD would be equals to the unit of F, over the unit of A rho V square. Now, some of the quantities here, the units you've already found from the previous example, such as for force, density, and velocity. So subbing in all the units, for force, it is kg meter per second squared. For area, it is meter squared. For density, is kg per meter cube. For velocity, it is meter per second. Remember to square the term. Then now, the unit of CD will be equals to kg meter per second square at the top, and also kg meter per second square at the bottom. This in turn becomes kg power 0, meter power 0, second power 0. So for this quantity, there's actually no units. You may have noticed that during the analysis, I've ignored 2. Now the reason why it's ignored is because 2 is a number. It has no units, so it's not considered inside the analysis.